all in all, today's section is not overly difficult. In fact, we have touched on a lot of it already. But we're going to look at a little bit more complex problems as we go along. Most of us know that the longest side of a triangle must be opposite the biggest angle. Okay, you probably know that. And the shortest side then must be opposite the smallest angle, and so the medium side must be opposite the medium angle. Nothing big there. And the converse of that is basically saying that the biggest angle must be opposite the longest side. It's just saying it backwards. It's the same thing. And so if we take a look at this one right here, which side must be the longest? Well, if you take a look at the angles, here's 40 degrees. That's the smallest angle. So that one there is the smallest. If that's 80, this one over here must be the biggest, and this is kind of in the middle somewhere. And so for this particular one, which side must be the longest? CB, or can you say it BC? Is that okay here? Yeah, order doesn't matter. And then which one did you tell me had to be the smallest? Well, if this is 40 degrees, that one over there, AB, must be the smallest. So that in itself is pretty straightforward, but it's really nice if I only give you one triangle. It gets a little more complicated. But why don't you try this one, just take a second or two, and figure out which angle must be the biggest and which angle must be the smallest, I should say. They're not shortest. That's not very good grammar. So which is biggest and which is smallest? Is it okay to just use one letter on these, or do you have to do like, you know, Y, X, Z or something like that? Yeah, you can just use one, because there's no confusion, right? If I say angle Z, we should all look at the same thing. If I say Y or X, we should all look at the same one. So which angle is the biggest? Angle, and what is your reasoning for that? Yeah, here's 23, so that means that's got to be the biggest. Does it necessarily look the biggest? Kind of. Remember, it looks like it is very dangerous. Okay, don't use those particular words here. And then which must be the shortest? Well, this has 18 and that has 14, correct? So 14 tells me that one, angle Z, and I normally do that with my Z's so they don't look like 2's. Okay? Angle Z must be the shortest. So if I just give you one triangle, this is very simple, isn't it? But what if we start putting several of them together? These rules that we just looked at only deal if you're looking at one triangle. You have to somehow relate the two triangles together if you're going to try this with more than one triangle. So if we take a look, it says which is greater? Angle CBD. Where's that? CBD is right there. We'll do it in green. And CDB, put it down there like that, is in blue. So the first thing you should kind of think of to yourself is, are they dealing with the same triangle? Actually are, aren't they? So this bottom triangle of ABD really has no bearing on this problem, correct? It might on some of the later ones. So this should be pretty straightforward. Across from the blue angle, I have 16, and across from the green angle, I have 15. And the question wants to know which is greater then. So is it the green one or the blue one that's going to be greater? Yeah, CDB, or the blue one, has to be bigger because it has 16 across from it. The green one only has 15. Okay, so it is actually that one. And again, that's kind of how I do those. You can write it in if you want, or just circle the answer. So that's if it deals with the same triangle. Let's see if the same thing happens with the next one. Once again, I will color code it for you up here. A little bit easier to see. So ADB, where's that? So ADB we will do in red. And in green, DBA. So DBA. So that one's green. And then what's that symbol asking? Yeah, greater than, right? So is ADB greater than DBA? It's kind of a mouthful. That's why we'll say red and green. A little bit easier, right? So green has what across from it? It has 8. And red has 10. And it's dealing with the same triangle, so we can actually use that idea. And so, in other words, the red one is bigger or no? Red one is bigger, and is that what this is saying, that the red one is bigger? So we would say, yes, it is. Okay? So just circling in that instance kind of really doesn't answer the question, right? So you have to be careful with that. Are there any questions so far? All right, we'll color code one more time. CDA. Ooh, that doesn't even deal with a triangle. All right, well. And then CBA. Wow, that's interesting. That's dealing with the quadrilateral, not a triangle, right? Everything that I told you earlier today, if you look at the directions or the title of this, says sides and angles of a triangle, not of a quadrilateral. So how are you supposed to figure out which one's kind of bigger? You got to be very careful. This is a very common mistake that people make. Okay? So maybe I should put green here, right? You have to be, because sometimes you can't answer these types of questions. So let's see if I can answer this one. If I were to just look in this bottom triangle, do you agree I'm trying to use that angle, right? And then I'm trying to use that one, right? As far as green goes. And this one has, and this triangle has 8 across from it, and then in that triangle that is 15. Now some people say just add the two together, it gives you 23. Okay? That is a very poor choice to try and do that, because we don't necessarily know if that's true. But what you can do is find out, is it, say, the biggest or smallest angle in the respective triangles? Okay, that's one thing you can actually do. So you take a look. In this bottom triangle, ABD, is this angle that we're using in green, is it the biggest angle or smallest angle for that triangle? Just that triangle. It's the smallest, right? How about in this one up here? Is it the biggest or the smallest? Or, well, in this case, it's the middle, right? So that's interesting. Well, let's look at the other one. We're looking at, say, that one and that one, right? In this triangle, it's the middle. And in that triangle, it's the biggest. So we're going middle, biggest, and middle, biggest. Any idea how we can figure out which one has to be greater? Do we know for sure which one has to be bigger? Yes? Not quite. I like how you say that, like 16 and 10 are bigger than the 8 and the 15, respectively, but that still doesn't necessarily get us there. That would be the same thing as just adding, because the one gives us 8 and 15, which is 23. The other one gives us 26. Any ideas? We don't know it's a right triangle, so we can't use Pythagorean theorem. I can wait. I could just give you the answer, but I want to make you think. CBA. What's that? Not necessarily. Yeah, that's a big no-no. Yes, it looks like it. Yes, the age-old wrong way of doing it.
We could use a protractor.
Maybe not be drawn. Might not be drawn to scale. Nah. Yeah, just it is drawn to scale. Yeah, just write that underneath and use a protractor. Yeah, that works. Yeah, and that's the way to do it. You know it. Well, perhaps we'll leave that one and we'll come back, see if your brain works on that one. Yeah, because I want you to figure it out. Let's go to the next one. It says if CBA. So where's CBA? DBA. I was going to say, where's that? So DBA is congruent to CDB. So that means they have the same measure. Do they look like it? Nope. Doesn't matter. We were just told that they do. Then which angle in either of the triangles has to be the biggest, if I know that? So some people like to just put numbers there. So let's put a number in there. Let's put 80 degrees. Because some people like numbers. And maybe 80 was a little big, but it'll work. Degree 80 degrees has to be the what in the top triangle? Biggest, smallest, medium? 80 degrees is the smallest down there, correct? So do both of these angles down here. Yeah, so 80 was a horrible choice. But you get the idea. Do both of these angles have to be bigger than 80? Yeah, so 80 is a terrible choice, but you get the idea that both of these have to be bigger than that. Do you agree both of these up here have to be smaller than 80? So it has to be one of these down here. And which one down there is going to give me the biggest, angle A or angle D? Is angle A going to give me the biggest? Yeah, it has 12 across. Right? So yeah, 80, we could go back and choose a different one, but that's okay. We know that angle C up there and in this angle B right there have to be smaller than 80. These two have to be bigger than 80 based on the triangle. And so A has to be the biggest overall over this entire picture, correct? And so the answer for the biggest angle is angle, but could you just say angle A? Actually, can't you just say angle A? There's only one there. But yeah, let's just do D, A, B has to be the biggest. You know why most people don't think that can possibly be the biggest? Well, for one, it doesn't look like it, and it has 12 across from it, and they say this one up here has 16 across from it. It doesn't matter. Just because 16 is bigger doesn't mean that angle's bigger, because it's two different triangles. Okay? Yeah, we'll come back to that one. Let's not forget about that. Okay. Given the angles in the figure at the right, answer each question. Which side of triangle RTU is the longest? RTU. Can we figure out this angle? What is it? How'd you get 70? What's this called again? Straight angle or linear pair. So 70 is used up. 30 is used up. How much is left over? 80. So which side must be the longest? We got 38 degree angle, 80 degree angle, and 70. Which one's got to be longest? Yep, TU. Is it okay to say UT? Yeah. There's no congruence here. Which side of UST is the longest? YTS. Yes, it looks like it defense. Yeah, that's 110. Are we going to get anything bigger than 110 in this triangle? No. Yeah, the other two must be acute, so that is TS. And it says if TU is an angle bisector. What that means is TU is cutting it in half. So that and that must be the same, correct? So what can I put there if I'd like to? 30. Then which side of triangle RST? So the big one, right? Which one has to be the biggest? Well, we can get this angle now, can't we? We got 100, we got 30. So are we sure with 40? Because 110 and that is 140, right? So 40 is left. Okay. Can we, well, we already know this one right here. What is this one again? And what was this one then? So now that we got that 30, can we actually go and get all these angles? We can. And for those of you that want to see it, let's make it bigger. You don't have to do this, but here's R, T, S. What's this one? There isn't. It's the big one. This one is? Here's what most people get wrong. What's this one? 60. Very good. You got to add them together. So now can we tell which of R, S, T is the longest? It is TS. So you notice once we start putting more triangles on there, this gets a little bit more complicated. Any questions? Determine the value of x and list all the sides in order from shortest to longest. Please watch out, I won't always do shortest to longest. I might do longest to shortest, and then you'll feel silly when you put them in the wrong order. So it says we've got a triangle ABC. Got it. So just draw a picture. Angle A is 3x plus 20. B is 2x plus 37. C is 4x plus 15. Is this something we can calculate? Sure. We have all three angles of a triangle, and we know that all three have to add up to 180. So we've got 3x plus 20 plus 2x plus 37 plus 4x plus 15 equals 180. Yeah, combine like terms. Again, don't do the maneuver I've seen some people try and do at this point. I don't know where this algebra came from. Oh, let's subtract 2x from this one, subtract 2x from that one. They're not on different sides of the equal sign. Don't do that. If they're on the same side, combine them. So we got 3x, 2x, 4x. How many x's are we looking at? 9. And then we got 20, 37, and 15. What is it? Are we sure on 72? I've heard a variety of answers. I know it's early, but come on now. So we got 57, right? If we put these two together, it's 57. 67, and then 72, right? Equals 180. Could you divide by 9 right now if you wanted to? Actually, here it's not that bad a choice because they all divide by 9. Okay, but you have to divide everything by 9. But let's stick with the way that you've been wanting to do it, or been taught to do it. X is 12. Well, it said determine the value of x. Check. We did that. Now it also wants me to put the angles in order from, I should say smallest to biggest. I could actually ask you for the sides too, so make sure you give what's asked. Oh, it does say list the sides. Well, good thing I read that. Let's put 12 back in. So put 12 right there for x, 12 right there, and 12 right there. So angle A is how much? Are you sure? Angle B, 61. Angle C, 60. Are we sure? Because if we add those up, it better add up to be 180, right? Does it? Yep. So now it says sides from shortest to longest. So which side is the shortest? Yeah, it's right here across from this one. So BC is the shortest, followed by, yep, AC. And yeah, it better be the last one, right? There it is. So any questions? Has anybody come up with the answer to the other question? I don't think going to problems that you don't get and skipping them is a good way to get through life. We're doing a comparison. This might be helpful. You never know. Let's look at, say, let's forget about this and just look at, forget about that for right now. Let's just compare those two. I hope you agree that the blue angle that you see right now and the green angle are part of this problem. Which is bigger, blue or green? Blue is bigger, correct? So how about we give blue a check mark for right now for being partially bigger at this point, correct? Because we can actually compare those two, right?
Yeah.
Now let's go and do the other ones that are part of this problem. The other ones that are part of this problem are that for blue, correct? And then that for green. Which one's bigger, blue or green? So blue gets basically a double check mark. So both parts of blue are bigger than the parts of green. Okay. Now does that mean you can just sit there, oh, add the 8 and the 15 and the 10 and the 16? If you try that, I guarantee you will get one wrong on your assignment. Because there is one on your assignment that does not work. But if you ever get stuck, start comparing it to things that you can actually compare, which are things in one triangle. You can do that. Unless they start giving you stuff like this. Then you can start comparing the triangles a little bit better. So basically, blue got 2 check marks, so that one's got to be bigger. Because both parts are bigger. So, giving up, was that really necessary? No. Now, here's unfortunately what some of you will do. You get there, you'll give it the it looks like it defense, and you'll just circle one of them instead of actually trying. Okay? Yes? Very good. Here's the question I was waiting for. What if you did that comparison and you got 1 check mark here and 1 check mark there? Either you find another way to do it or we just can't tell. Undetermined, yeah, we can't do it. Because when I looked at them, one was bigger, and because we don't know the angles. We're just comparing their size. Okay? So great question.